Welcome to UGC E-PG Pathshala lecture series in computer science. In this series of lectures, we have been looking at a paper, database management system. And for today's lecture, I will be continuing on the database manipulation commands and its transparencies. The learning objectives for today's session will concentrate on use of group by and halving class, subquery and nested subquery, multi-table queries and the different joins. First we will look at the use of group by class. Understand the natural language query, find number of staff in each branch and their total salaries. So this may be converted as select branch number, count the number of staff by staff number as my count, sum of salary as my sum from the staff table, group by branch number and order by branch number. So as related in the query which says finding the number of staff in each branch, I have listed branch wise. Branch number is the initial value. The second projection is on my count. So my count is also been given. The third one is on my sum. So the branch number has been indicated, but as such in the second value it has to list the total number of staff and count the number of staff. So branch 003, the number of staff is 3, branch 005 which has 2 staff members and branch 007 has only 1 staff. And their total salary means sum of salary for these 3 people, and total we have been distributing them with 54,000 say. For the branch 005 the total salary is counted to 39,000 and branch 7 we have 9,000. We have grouped it by the branch number and we have ordered it based on the branch number starting from 3, 5 and 7. So now that we are slowly progressing towards higher sets of queries starting from select from, select from where, select from where, order by, select from where, halving and select from where, group by. Restricted groupings within the halving class. Halving class is designed for use with the group by to restrict groups that appear in the final result table. This is similar to where, but where filters individual rows whereas halving filters groups. Column names in halving class must also appear in the group by list or be contained within an aggregate function. This is just an example of the halving class. For a query of this format, for each branch with more than 1 member of staff, find the number of staff in each branch and the sum of their salaries. So concerning with the previous query, anything which has got more than 1 staff member, so it should be actually with 2 and more, I want to find out the number of staff in each branch and their salaries. So we are trying to refine with the previous query where branch number has been indicated B003, B005, in the previous result we had B007, but the total count of employees or total count of staff in that particular branch was only 1. So now we have eliminated that. If we represent it by a SQL statement, it should be like select branch number, count staff number as my count, sum salary as my sum from staff. This is how we have represented in the previous table. Order by branch number. Now that we have introduced group by branch number, having count staff number greater than 1. So this is what is the recent indication which says any branch which has got more than 1 staff need to be highlighted based on their staff number and the total salary. I repeat, group by branch number having count staff number greater than 1 has completely avoided anything which had got count as 1. We will talk about subqueries now. Some SQL statements can have a select embedded within them. A subselect can be used in where and having clauses of an outer select, where it is called a subquery or a nested query. Subselects may also appear in insert, update and delete statements, which are supposed to be your manipulation commands. Subquery with equality, which means I have another list of the same select from where type with a condition to be checked, checking for an equivalent constraint. In this case, list staff who work in branch at a specific address. Select staff number, first name, last name and position from staff table, where the branch number is equal to select branch number from branch table, where street is equal to the same as indicated in the query. So now this will represent a person who was working on that particular street alone will be retrieved. Subquery with equality constraint extends still more. An inner select finds branch number for branch at this address. An outer select then retrieves details of all staff who work at this branch. So there are two different kinds of select, one is an inner select and the other one would be an outer select. So select staff number, F name, L name, position from staff, where branch number is equal to B003 would retrieve on one specific value, which is supposed to be a inner select. Depending on B003, any value will be taken out, but then the outer select details of all staff who work at that particular branch. The next query will be on the subquery with the aggregate functions that we have used. So to recall, the aggregate that functions that we have looked at in the previous session were count, min, maximum, average and sum. So list all staff whose salary is greater than the average salary and show by how much. So select staff number, first name, last name, position and salary minus select average salary from staff as salary difference. So now that I have to project a common table which shows this salary difference, which will be selected from the salary minus average of the salary of all the staff. So anybody who is getting say 30,000, the average salary is 17,000, the salary difference is 13,000, that should be calculated and projected as a separate attribute from the staff table, where salary greater than the average salary. If I have not mentioned this particular constraint, then there may be chances of getting a negative salary also. People who are getting salary of 9,000 and the average salary of the entire table would have been 17,000, 9,000 minus 17,000 would fetch a negative value. So for those reasons, I am projecting this as anybody with a difference in salary greater than that of the average salary will alone be considered for this query. So this will project a resultant of a person of manager category has a salary difference of 13,000, whereas a person of supervisor category or position has a salary difference of 1,000 compared to the average salary, and a person of manager who holds a lesser salary than the senior manager or so will get a salary difference of 7,000. And here we cannot write where salary greater than average of salary, instead use subquery. So this kind of average statement cannot be used within this greater than symbol or so. So for those reasons we have used a subquery to find average salary of this thing, and then use outer select to find those staff with salary greater than this. So select staff number, first name, last name, position and salary minus 17,000 as salary difference, that is what we have computed initially. from staff where salary greater than 17,000. So this is another format of writing, but then to understand this easily, we would have performed our manual calculation, our own manual calculation to present it as 17,000 as the average salary and salary greater than 17,000. To avoid this, we have gone for representing in this manner. So I repeat this particular query, select these list of values. In addition, I have another attribute which has salary minus select average salary from staff as salary difference. So now this salary difference will present me with average salary of this would be 17,000 to be subtracted from the actual salary, and salary should be greater than the average salary. So some of the rules that we may have to consider while writing your subquery are: order by clause may be used in a subquery, although it may be used in outermost select. Subquery select list must contain a single column name or expression except for subqueries that use exists. By default, column names refer to table name in from clause of subquery, and it can refer to a table in from using an alias symbol. When a subquery is an operand in a comparison, subquery must appear on the right hand side. A subquery may not be used as an operand in an expression. As part of this subquery, as an extension of this query, there can be a use of nested queries with the use of in as its operator. List properties handled by staff at a street. Select property number, street, city, postal code, type, room, rent from property for rent table, where staff number should be in. Select staff number from staff where branch number is equal to, select branch number from branch where street is equal to this. So why should we use unnecessarily so many number of subqueries? To avoid major of the complexity by unknowingly typing on some value which we may have to exactly represent. So it will initially process on this internal statement, it will select branch number which has got this as the branch street. From that it will go to the next advanced query where staff number should be in this particular relation or should be in this particular resultant, and from where we may have to project only these values. Now that we will be looking at the operator any and all. Any and all may be used with subqueries that produce a single column of numbers. With all, condition will only be true if it is satisfied by all values produced by the subquery, whereas with any, condition will be true if it is satisfied by any values produced by the subquery. So that is what is the difference. Condition is true only when all the values of the subquery is been true, whereas any, if any of the subquery condition getting satisfied, so this any will be true. So if the subquery is empty, all returns true, whereas any returns false. Some may be used in a place of any. So instead of any, I can use SOME also. So use of any or some at appropriate places. Find staff whose salary is larger than or greater than salary of at least one member of staff at branch B003. So how should we represent this in a SQL statement? Select staff number, first name, last name, position, salary from staff table, where salary should be greater than sum of select salary from staff where branch number B003. So that will retrieve some of the values. Inner query produces a set of say 12,000, 18,000, 24,000, and outer select query lists those staff whose salary are greater than any of the values in the set. Now we look at the use of all operator. find staff whose salary is greater than salary of every member of staff at branch B003. So anybody who holds a salary greater than that of every member of other staff at branch 003. Select staff number, F name, L name, position, salary from staff table where salary greater than all with the nested query of subquery of select salary from staff where branch number is equal to B003. So for which the resultant is this. Now we will indicate multi-table queries. This multi-table queries can use subqueries provided result columns come from same table. If the result columns comes from more than one table, then we may have to appropriately project joins. So to perform a join, we may have to include more than one table, one or more table with a from clause in it. So using comma as a separator and typically include where clause to specify join columns. Some of the examples of this multi-table queries might include, and these also possible to use an alias from the table named from clause. Alias is separated from the table name with a space. Alias can be used to qualify column names when there is an ambiguity. Initially to project with, we will just give an explanation of a simple join. To use a join, we have considered this query: list names of all clients who have viewed a property along with any comment supplied. Select C.client number, first name, last name, property number and comment from client stored as C and viewing as V, where C.client number should be equal to V.client number. So by checking for a simple condition of say one table stored as C client and the other table stored as V as viewing as a property, by looking at the client number of both the tables C and V, if those two are matched, C.client number and V.client number of client and viewing table, if it matches, then it has to appropriately project C.client number, first name, last name, property number and comment for the same table. So only those rows from both the tables that have identical values, similar values in the client number columns, that is with the condition of C.client number is equal to V.client number, are the outcome of the result. This is equivalent to equi-join that we have seen in the relational algebra. With the relational algebra, we would have used a symbol called a join with the condition of C.client number is equal to V.client number. So this will say client number by looking at two different tables C and V, that is client and viewing. If both the table has got equal client numbers like CR56, CR62, CR76, then those list along with its other attributes as listed in the query will be taken. There are alternative join constructs. These alternative join constructs are as follows. SQL provides alternative ways to specify join. From client C, join viewing V on C.client number is equal to V.client number. This may be slightly complicated. There is a table which has got client C and there is another table which is called viewing V. Then now that I use a common English language join on with the condition C.client number is equal to, instead of direct representation of C.client number and V.client number, this condition is being provided like in the previous case I have indicated this in the where condition where C.client number is equal to V.client number, but here I have introduced select with the same list of attributes. From condition itself I am projecting the where condition clause. From client C, join viewing V on C.client number is equal to V.client number. From client, join viewing using client number. This also is an alternate form which shows C dot client number is equal to view dot client number, which matches both of. So instead of on, if I try to use using, then it checks for the client numbers, matching the client numbers equivalently, and then fetches out the result. There are alternate ways of doing this also, from client natural join of viewing, which is an indirect representation. As we have indicated on the using equi-join, natural join also does the same purpose, where C dot client number will be checked with V dot client number. So in each case, from replaces original from and where. However, first produces table with two identical client numbers. So in the first case, if you look at, it will present C dot client number, V dot client number, first name, last name and other values. So which is unnecessary. So we can avoid these duplicates also by directly mentioning on either natural join or by representing it as where condition. How should we go with sorting of a join operator? For each branch, list numbers and names of staff who manage properties and properties they manage. Both are slightly different. List numbers and names of staff who manages property and properties that they manage. Select S dot branch number, S dot staff number, first name, last name and the property number from staff property for rent P table, where S dot staff number is equal to P dot staff number, and order it by S dot branch number, S dot staff number and property number. Tries to list in terms of branch number, staff number, first name, last name, property number, and it orders it by S dot branch number, S dot staff number and property number. So this is how it has been listed. Now we will look at how to, so far we have been looking at two table joins. Now we will be looking at how to combine three different tables. For each branch, list staff who manage properties including city in which branch is located and the properties they manage. Select B dot branch number, B dot city, S dot staff number, F name, L name, property number from branch table, staff table and property table, where B dot branch number should be equal to S dot branch number and S dot staff number should be equal to P dot staff number. So there are three separate tables. One is called a branch table, the other one is called a staff table, the third one is supposed to be a property for rent table. Between two different tables I am matching B dot branch number and S dot branch number, and with the other table I am matching S dot staff number and P dot staff number, and I am trying to order it by B dot branch number, S dot staff number and property number. So the resultant of this particular table will be in this format: branch number, city, staff number, F name, L name and property number, where this is being ordered based out of branch number, staff number and property number, but the condition checked for three different tables. One was with branch number between B and S, the other was with staff number of S and P tables. So there is an alternate formulation for from and where. From branch B, join staff using branch number as BS join property for rent P using staff number. In summary, in this particular session we have started by looking at group by and halving class, which is in continuation of the order by class that we have studied in the previous session. Then we have listed out the queries as subquery and nested subqueries with different constraints, and further we have condensed ourselves with use of any and all within the queries. And later aspect we have seen to the flow on different joins that we were trying to use. As an initial case, we have started with a natural join or an equi-join statement with different alternative strategies. How would it be when I have used a constraint of matching the client number with an equal to symbol, or equating it with the natural join within the from clause and things like that. But these joins have been performed with two tables, say considering two different tables as client table and viewing table. Later on, when we have introduced on property for rent table, that is the third table, we have seen how to combine three tables given a constraint. Thank you.